The library of functions can have multiple transformations within them. Being able to do this requires that you know where the numbers for the transformation go. You need to be very mindful of your signs. So we're going to start with the first one. We have the parent function of y equals x squared that is shifted up 4 units and left 3 units. So y equals x squared. So our new function is going to be y equals parentheses x squared. So we have, first off, left 3 units. So when something goes to the left, it's a negative. So it's going to be x minus negative 3. And up 4 units is a positive, so it's going to be plus 4. Now we need to simplify it down, so we got double negatives in here, so we can rewrite this as x plus 3 squared plus 4. And this is the new function with the given transformations. Next we have y equals square root of x. It is shifted down 1, shifted right 2, and reflected about the y-axis. So y equals, we're going to have square root of x here. But let's start working with what we got. We got down 1 unit. So we know down 1 unit is minus 1. That goes on the outside of the function. Right 2, since it's going inside the function and right is positive, so it's going to be minus and then a positive 2. Now this is what you got to be careful for. Reflected about the y-axis. That means we're going to have a negative, but it's going to be inside the function like so, but the negative accounts for everything in here, so this needs to be in parentheses like so. And so we got this. You can leave it as the what I have written, or you could distribute the negative on the inside, and you could have negative x plus 2 minus 1, like so. Either one is acceptable, just a matter of preference of which one you would prefer, but in either case, both of these show the exact same transformation given. Next we have the function 1 over x, and it is shifted left 7, and it's actually stretched vertically by a factor of 2. So I mean shifted 7 left and stretched vertically by a factor of 2. So shifted 7 to the left means it's going to be inside of the function, so y equals 1 over, and left is going to be a negative, so it's going to be x minus a negative 7. But stretched vertically by a factor of 2 means it's going to be multiplied by 2. So essentially 2 times the entire function. And we can clean this up a little bit. We can move the 2 on top, like so. And then double negatives, we can say x plus 7, like so. And this would be the new transformed function. Last, we got y equals absolute x. This time it's shifted right, compressed vertically by a factor of 1/3, and reflected about the x-axis. So we got a bunch going on here. So we got our function, y equals absolute x, and we are shifted right 4, so right is positive. So it's going to be x minus a positive 4. It's compressed vertically by a factor of 1/3, so that means in front of the whole function we're going to have a 1/3. And it's reflected about the x-axis, so we're going to have a negative in front of the whole thing as well, like this. And I'm going to make sure we emphasize this is absolute value, not another 1. So we got negative 1/3 times the absolute value of x minus 4. Nothing else you really need to do here. So this is our new function for these given transformations.